Hello, everyone, and welcome to another Directions Mag Geospatial webinar, today sponsored by our friends over at OpenSpatial. I'm Barbara Duke, Managing Editor here at Directions Magazine with our assistant webinar producer, Lynette Qualia. Thank you to the geospatial community for stopping by directionsmag.com for articles, news, and of course, more webinars and podcasts. A warm welcome to Colin Hobson from OpenSpatial. He has got some great tips and things for us to learn about our work in GeoBIM, digital twins, and your use of CAD.
Yep, thanks, Barbary. And so what I'm going to do is look at the aspects to consider when automating or considering doing essentially an automation of the loading of CAD drawings into GIS, GeoBIM, and digital twins. And so the first question is, well, what exactly are we doing? And so this is about automating the direct loading of data. And if we step back just a little bit in the entire workflow, there's, the design, build, manage, plan. And if you look into that, in essence, in design, that's done either in 3D or 2D. And then when it gets to build, there's generally a flip around to 2D at this point. And so we're going to focus extensively there because that's the handover. And I would contend that the GIS industry is far behind the building industry, the AEC industry. When buildings get handed over, they're getting a complete set of asset information with the building. And just from the poll we had, whether it was CAD drawings and or PDFs, when utilities or new developments outside the building data gets handed over, it's typically in either paper files or PDFs or CAD drawings. And we're nowhere near GIS features, not to mention, any kind of digital models at all. And so let's drill down into that. So the what is really about in this presentation, it's about this little piece here. And if we look at that, we'll go all the way down into design, plan check, and then there's a big construction phase, which could take years, and data captures. At the end of the day, we're about what data do we have? And if you don't have data, you're not going to get to be able to do any kind of GeoBIM, anything like that. You're just not there. So that's sort of the drill down. But before you get to that, what we found is that there's a few reasons for why people would want to do this. So why do you want to get real data into your system? The first one is just to enable automating submission of as-built plan submittals, just to automate getting them so that people can do it. So becoming essentially digital, and I'll come back to that in a minute. Also making it speed up the process of acceptance of of data and project information, but also getting that into your GIS. Typically the backlog between data coming in and when it's put in, there's anywhere between 1 month and 3 years. It can be a long time. And then also people get information that's not been validated. In other words, you can't guarantee that what's in the CAD drawing or even on the PDF is complete, that every depth, direction, etc. is there. And so it becomes a big challenge to capture that data. So automating it, the whole point is to reduce the backlogs, to standardize and make sure that you can guarantee what's coming in. And the result of that is improved data, because if you automate it, you can check that every drop inlet has a depth, has a room or a cost elevation on it. Whereas if that's done by hand, that's a bit of a challenge. And the cost savings, typically, and if you look at the case studies we've provided, and as a company, we've been doing this on the particular product I'll show you later on, maybe if we get to it, is, we've been doing that 10 years, and the cost savings is anywhere between 5, 10, or 20 times, because recapturing something that was already drawn in a double precision accuracy in CAD with survey monuments and all of that. If you set that up right, there should be no reason why you cannot have that as accurate, complete information. So let's step all the way back out of that CAD thing and go to what we're going to look at now. And I'm going to run through each of these. So we look at organizational things, workflows, automation, data models, CAD aspects, data validation aspects, and GIS. So we'll run through each of those, and I'll start with the business. and it's a mess. There's a lot. And so the organizational, just stepping all the way back to the high level, how do you deploy, what are those aspects to consider when you deploy this kind of solution into an organization? The first one is is somewhat of a shocker in one way and absolutely visible and understandable, and that is that many organizations, cities, counties, utilities, do not have the desire to even enforce standards when data is submitted. And so that's a big challenge, and that's at executive management level. Are organizations prepared to even say, when you provide us data, use this? Assume they do, then we can go into the rest of this discussion. The other thing is who covers the cost. If you are recapturing data, then by default, your organization is covering the cost of recapturing, sometimes even having to go out and resurvey data in the field, and that cost is on your bill, and it will be more than just the little permit cost that goes with it. It's a full-time equivalent doing detailed data work into your system. It's also multi-departmental, so sort of nobody owns this, but it is a huge piece to the data economy within your organization that's just slowing down what comes in, what's the quality, who does it, and what's the reliance you have on those people. The other thing is, if you do something, is it going to be easy to deploy? And what's it going to change in your all the different processes? There's also a lot of documents that go with. It's not just the plan. There's all sorts of schedules and permits and inspections. There's various people to get notified along the way within the group, interactions, whether it's been the inspector or permitting or engineering compliance, etc. And if you did do a going digital, is it cost effective? What's the ongoing ROI? And actually that is an absolute no-brainer. It absolutely does save time. Does it change the process? Yes. Is it something that requires multiple people's input? Yes. And that's the biggest challenge. This is not actually, it's no longer a technology challenge, and I'll show you that. So let's jump into number 1 on the 7 here. There are lots of different parties, internal and external, involved, and there's workflows. And so you need to be able to automate not only the capturing of those files and documents, but also the status and the interaction. There's different users. And so as an organization, you want to be able to set up what we call notification sets, where you can define roles and easily assign those within, so that when a plan comes in, it lets the right people know in your organization what stage it's in, what approvals it's at, and feeds that back. So this is something that makes that organizational piece a whole lot easier. There's different stages. There's all these departments and sign-offs, things like engineering, permitting, inspecting. And if this is actually a workflow, and there's different kinds of projects, a new development versus a building modifications. And you may have different requirements with the site review and what documents go with, and irrigation or planning or whatever. And if you look at this, essentially you're going from a design document to an as-built. And that raises another question. That is, how do you check that what they actually give you as the digital document, this is something you need to consider, does match, the as-built? Because if they just give you the design version and it doesn't have any of the changes or details, then that's a challenge, and you need to look at that. Let's go to item number 3, automation. So when we say automation, well, what do we mean? What's the levels? If you're getting PDF files, some of those can be analog and or vector. If they're vector, at least you can convert them, but guaranteed they're probably going to be not geo-referenced, and that's going to be a challenge. If you're getting drawing files, CAD files, then those are at least vector graphics. And most of the tools that are out there now, if you take a CAD drawing, there's no problem importing that, using it, loading it, looking at it in GIS programs. The problem is not the vector graphics, it's the attributes. The vector graphics is easy. You're going to get what I call dots and lines. You're going to at least have a layer, but it's the attributes. And so that's sort of where this whole CAD GIS thing started, which I guess I've been doing for 20 years. But it's a challenge. And then once even if you can get the vector graphics and the attributes, you also have to decide, well, what is required? What information should be on that data? We can look at it. Automation also, technology-wise, can people push a document into the cloud or on the portal? Do they give it to you on a USB stick? Do they come to the, do they email it in? How do they do it? Do they push it as an attachment within a system? And then who actually looks at that? Is it get opened in a desktop? How do they view it to check it? Is the combination of those? And so these are challenges. And then further down on the data level, when you get to GIS, there's actual challenges in terms of, well, where do you store that? Where there's a repository of documents? What is the history of those documents? How are you going to record that in the future against those projects? And then within that, how do you put that in which GIS databases? What about planning and staging and production? So automation is an item. You should look at that, and that's an aspect to consider. The other one is the actual data itself. So if we drill down into the data models, I often ask people, do you have a standard? And then they say, well, what, yeah, we have our GIS schema, or we have a CAD standard. And I'll look at that and I say, well, that's a challenge, because at least if you have a standard, that's going to help a lot. If it's a CAD standard, that determines at least the namings that goes on there. And if it's a GIS, then it's a CAD standard. So here's an example of one of ours from a national CAD standard-based naming conventions used, which at least then means the CAD folks have a standard way of looking at how drawings and things are put together. But in the data model, CAD standards generally, you have to look whether they split out the geometric entities into points, lines, and areas, and then how to deal with those and how to name them, and that becomes useful. So do you have a CAD standard? Do you have a GIS standard? Interestingly, a lot of people will say no, and I'll say, well, actually you do, because whatever your features are defined in your system, if you've split them or grouped them and they're going to name, say, for water, within those features, you already have then columns assigned and values assigned. That, by the way, is your data standard on the GIS side of the house. On the CAD side, it could be anything, but on GIS, that is your data. The customer off-the-shelf standards, you need to be able to look at whether you can adjust your own standard to do that. And thanks for catching that. When I ask people whether they have a standard, they typically say they don't. And I actually say, de facto, you do. If you have it in GIS, you have defined what your features are, what your columns are, what your domain values are. You have a standard. On the CAD side, people will say, yeah, we have a CAD standard, but we can't enforce it. We're really, we can't use that. And then furthermore, the biggest challenge is the attributes. So GIS knows what attributes are there. Those are there by definition. But CAD, it's a whole different ballgame. And so I'm going to move on. We've covered 4 aspects, though at a high level in an organization, these are the things to look at. Let's get a little more specific within, say, this CAD GIS thing and how we can get that into our models, and to look at that. So on the CAD side, there are a few things to look at there. There's different technologies of CAD, and I'll just address another one. Within the CAD organization, industry, there's also what kind of CAD are you talking about? There's traditional CAD, which is predominantly 2D, but AutoCAD, BricsCAD, any of those products would have the plans, and that's still where I see the bulk of the documents coming from. Would have been another poll question, and that's different CAD than, say, Civil 3D or Revit, which, for as examples, these are model based, and so everything's within the model and they're objects within the model, as opposed to CAD where it's entities within the drawing. And so there's a difference into how you deal with the attributes within these. Within the Civil 3D and Revit, that's essentially a revolution in our industry. The challenge is that construction bit on that workflow right in the beginning, that circular diagram. This is akin to moving from paper to digital, and how many years has that taken in our lifespan? And I think that's going to play out in our industry. Hopefully it'll go faster, and that future is a full-blown 3D, and that's what you're going to need. If you want a digital twin, you really need a full-blown 3D model. However, if we step back, for people where they cannot even ask people to submit according to a current standard, and most of their data is coming in as PDF or just unstructured CAD drawings, it's going to be a long walk to getting a full-blown 3D construction life cycle. And so I think we're looking at 10, 15 years before the industry actually catches up with the technology. What I'm going to show you now is that bulk of where it is now, how can we move that so that at least we can have GIS data directly? So the first thing is, how do you make it easier for CAD folks to get structured drawings? And the way to do that is to give them templates and layers and attributed blocks. And so if we just flip over to CAD, you can get yourself a CAD drawing, and it's full precision, it's located, except for the data itself is the challenge. If you look at the layers, there can be any kind of layer naming going on here. There can be, you know, the way in which these are structured. And if I look at a few others here, let's take, say, this one. So here, at least here, we've got layers that are, you know, National CAD standard compliant, but have they put the right entities on the right layers? And furthermore, how do we get to attributes? So if you look in here, here's, say, an asset. And on this asset, it's nothing except a dumb block. At least it has a name. So if you pull this into GIS, you're going to get a dot, and it's going to have, hopefully, a name called inlet paved. And that's all you're going to have. You're going to have to go and look to capture that data at this reference, which will be somewhere else. It could be in a plan and profile. You could check that, and you're going to have to get that information. So if you want the room, or you could look at this and assume that that's the room, and then you're going to recapture that because that's somewhere else. So that's a challenge. Another way of getting data is taking this document here and building it out with something like this, where you're actually using attributed blocks on CAD. So now if you say, well, my CAD standard requires the attributes to be on a block, and the block's a certain name, then that data there is an attribute. And a lot of folks use this because it's really good for editing purposes. And so this is essentially one of the things we've used on our product, because here's that actual data. Now, the moment you have data here, you can move that straight into GIS, you can validate it, and that becomes really useful. Block points are really easy. Lines are actually rather difficult. And so we actually have this notion where you put a label next to the line. In fact, we put that as an attributed block, and then those are attributes. And we then assign that on a given layer to this here, so that you can take those over onto the line and the area per se. So to make it easy for CAD, you can give them a CAD template. So they can load the template, and the template can be blank, and it could have all these layers by default. And you'll see this one's got 500 layers. So that's a challenge. If you tell someone, hey, use our standard, but there's a few hundred layers to learn, problem. So what you do is you put on a menu. So what we've done, for example, is National CAD standard-based menu. So that if I want to draw something like an easement, it's already there, and these are the layers, and that layer information is going to be useful to moving it over to wherever. And so by putting it on a menu, you're already putting it straight into CAD, and you can click on this and see that it is already on the correct layer, and you're going to match that back to your GIS. And so this makes it a very simple way to tell someone, look, you don't have to learn the layer names. You can literally just go through here and pull in if you want to put in, you know, buildings or easements or fuel oil, or if you go into stormwater, you'll see that all of this is built out. The other part is to provide them with blocks. So if I go in here and I do a CAD insert to put in a block, because that's what we've done, you can look at all these blocks. So once again, they need to know the name of the block. And these names, to learn that, is just more than anyone can figure. In fact, they may not even have all these blocks. So you need to provide this stuff. What we've done is stick it on a menu. So if somebody did say, take a block, for example, and put it in here, you can go in and say, all right, we'll put the block in. And if it's a CAD block, they can put the block in the drawing, and let's go and do it over here. So say we go here and they do an insert. You can see the blocks. They literally would need to do a browse or drag it out of the panel and learn those block names. So let's say they're doing a block. Say this is potable water and it's a blow-off valve. That one there, they would need to know those names, and so you can put it in. And even if they did know the names, when they put the block in, this is what you get in CAD. So this is great. We've got all the attributes that even they can match your GIS, but that's a problem too, because how do they know you know, what's required in each one of these, and it's completely free form, so there's no checking of that information, and that's a challenge. So one of the things we've done at OpenSpatial is created an AutoCAD plugin, and it's free on the store, and you can just go there. So now we put that on the menu, so that if somebody wants to put in an asset, they can go in and say, well, let's build out, say I'm just going to build out this this here and put a manhole in. I can go to the menu. That's going to get my already the layers, and I'm going to do this, but it's going to insert the block, and I'll just put it over here for clarity purposes. And it's going to insert the block, but it's a predefined block. And so this is attributor, where you have drop downs and domain values that match your GIS. And this is how you can give the tools to somebody and have them up and running within, you know, very easy, because the layer names are all standard. They don't have to use these tools. These are standard CAD blocks. If they just use the regular CAD commands, they could draw lines. And if they knew the layers, they could put them in. And so, you know, somebody can type in here, and if they had a reference, I'll just put in some, you know, numbers there. Say the depth is 6 inches, and an invert level is that, and so that would see. Let's say we just put in a number there, and so now you would have the block already predefined, and they could move stuff around and draw it and get the attributes. So just on the CAD side, a very important thing to be able to, you know, show that information and use it. In the Civil 3D and like Revit world, you're looking at objects, parts, and assemblies. And there it's actually even more difficult, because for everyone to have all of the objects and all of the parts with all of their names, this is a huge set of work that's been going on for more than 10 years already, and it's still somewhat incomplete, particularly in a lot of those things. So I've shown you the attributor add-in, and I've shown you the demo, so let me move on here. Let's go to the sixth and second to last aspect here, and that's validation. What do you actually check? What attributes are on there? And I showed you just briefly, you know, those attributes on these. And so here would be a fully attributed model here, where everything here has attributes. But what attributes do you put on? You know, what goes on the pipe? If you look at those properties, or actually, let's go in and just edit this guy, and that shows the attributes better. Let's go edit with attributor and do multiple. So there's tools here for doing multi-edits and all this stuff. So things like this, does your standard have this many things in it, or are there 30 or 40 aspects in there? And so I won't go into all the CAD editing tools, but this is a fully attributed model, and I'll show it to you just in a minute. As GIS data where it's been validated. So let's go back to the PowerPoint here quickly. So let's see this in action. I'll play this one. I've shown you live myself on my system, but here somebody is just pulling, and look at that menu, and notice when they put the hydrant in, it's going to pop up the attributor on a good day. So let's go back to that slide there, and just put it in presentation mode. Okay, we've done those. And so when somebody does validation here, you can, you know, go in and fill out the attributes and put that in there. Once you've built that drawing, what we've done with OpenSpatial is set up a little workflow here, and I actually skipped this slide. It's a little complicated, but if you remember at the beginning, there's CAD drawings, there's plan check, and then there's you know, data capture. If you take that toolkit and you draw a drawing, what we've done is set up a portal in a cloud where somebody can submit to that cloud. So using those standards I just showed you, you can go and submit to that cloud. And if you get errors, you can go and correct them. And then it'll actually output GIS data. And that's all online in the cloud. On the enterprise level, you can also combine that with desktop tools that look at your current GIS schema, get the feature names, and do in-house work and build out your own custom thing. So it's fully customizable to build out your data standards, and ties in with the clouds. And then associated documents and data standards, you can push those backwards and forwards. So let's just go and take a look then at this. So if we go to the portal, here's the portal in action. It's asconstructed.com, and each organization will literally get their own account, and they can go to validations. And if I took that CAD drawing, as a user, I would have, got an account and been able to submit to any given specific project within that organization, and the organization owns the what projects are set up. But let's just take a drawing, upload it here, and submit it. So now it gets pushed to the portal. The portal runs in Microsoft Azure Cloud at asconstructed.com, and each customer literally has their own portal. And so this is going to go in and upload that document. Once it uploads, you'll see it changes its status from the drawing gets opened and ripped through. So now we're applying those rules of what attributes, what feature types, and what actual validation rules get set. And so this is, if you go in and look at validations, this one has now been checked, and it failed. And they had a couple of hundred entities, 4 of them failed, and the user can go in and actually download. This is prior to any kind of submission. They can go and download and look at that data. So if they go to the action button, they can download the failed drawing, and it actually shows you the error markers within that. So they get a zip file, and in the zip file, there's 2 things: the drawing and the log file. And then I'll go and take a look at that. And so if we open that error file, this is the same CAD drawing, the way that hydrant was put in, and we can go and look at the errors. They've been marked with circles. So this is essential, because now people, and I'll actually pause this one right there, because that circle, they're different colored circles for attribute geometric errors. But this says, look, the domain value for pipe material on that particular one is wrong. It doesn't match what's going to go in the GIS. This is huge. Or there's data that's too long for what's going to be put into the model. And so you can look at that. So that was a point and a line example. Here's a area feature saying, so there was a point feature, a line feature with the, let's pause that. So this guy here was a point feature. This was a block on the line, and it's isolated, so the line's going to have an area. And then we go to that error there, which is the area feature that shows it's not close. I'm just trying to show the geometric primitives and looking at it. So that should be a closed area, and we want to be able to get attributes on all of those at the end of the day. So what we can do then is take a look at that. So let's go in and upload that drawing again, and this time submit it, and I'll speed you through that really quick. It gets uploaded a second time. This is kind of the workflow, because at this point the organization has not had to do anything except for the user to come in there. If it passes, at this point the user can go in and actually flag it as ready for review, which will start that whole workflow process. So it also converts that to GIS data. So actually, even at design phase, so you see all these shape files here, those were output automatically, because we know the feature names, we know the column names, we know the domain values. The drawings themselves are already set. We check the extent. So this is, what do you check for validation? Yes, you need to check that a coordinate system, that the values are within the coordinate system boundaries of what you expect, and you can set those. And so, I'm just getting a little too much in detail here. We'll come back to those aspects. But conceptually now we've had data checked, and we can actually come in and look at it. So if they download the GIS file, and this is portal only, then these guys can come in and look at it. So you need to define, if you're looking at GIS output, you need to define, what do you want as output? Is it okay to just get a standard set of named files where you know the name? At this point, we're outputting shape files and other GIS formats. But we can, you can literally then, once you have that data, you can push that straight into an online map. So it literally means at design phase with submittal, you'll have the proposed data available in a map, just like that. And then on the desktop, for getting it into your system, there's also challenges, because you can't just take project data and throw it into your master data set of record. You need to tie it in and look at a new and existing data there. So let's look then at that same drawing, and look at it in GIS. So here's that data in QGIS. And if we go in and click on a feature, you'll see these are all the attributes that came with that particular data standard. And that was a point feature. And if we look then at a polygon feature, line features as well, there's that polygon that was not closed, and then it got fixed and resubmitted. And so now essentially this user has gone from a CAD drawing to a GIS drawing, and it took about a GIS data set took about 7 minutes. And that then is essentially the 7 aspects to look at when you're trying to get to that technical stuff I've just gone into. So we kind of started high level and went way deep down. Biggest challenge for me that I found is organizations are not actually willing to step up and say, you have to give us a standard. And part of that is, well, we don't have a standard, and then what do we actually check and how do we check it? And so hopefully that's an outline there. So that's time up, and we're happy to type in questions so we can look at that. Here's a question. Since many CAD drawings do not use projected coordinates, how do you ensure that the CAD drawing can be imported correctly? Yep, that's a good question. One of the things we do specifically is, if say this was a CAD drawing, we actually check the min-max extents. And so when you go into a project, you can set a boundary, and we on the validation tool, we check the extent. So if this was a state plane, so in this particular model, this drawing actually has a coordinate system set. You can see it's a Florida state plane, and so these are feet, and we'd expect the min-max extents to be within the boundary. So that's useful. I mean, so you'll notice that this is in fact a georeference. So that's one thing we check on there. So if I go in and turn this on here and just put on an image here, sorry, I typed it wrong. GeoMap. And let's do hybrid there and zoom right in. So you can see this thing is located and ready to go. All right, other questions? Oh yeah, I didn't really mention the other one. So there are systems out there that do document management and do project management. And a lot of those, and most of those, what they're doing is the document. So you can take a PDF file and submit it against there, and you can even redline the PDF file. But the actual data within that PDF file is not being checked, and so that's a challenge. So you can track the whole workflow, and that I think is, well, I'm a GIS person, but I think management it's easier to sell a system that tracks the entire process within the organization than for the GIS person to say, hey, you know what, at the end of the day, we're getting this data and we actually have to put it in, and that's then being used for the next 100 years for managing these assets. So we should get it right. And by the way, what's happening with digital twins and GeoBIM models is it just shows the lack of good data, because the moment you look at it in the context of everything else together, you see what's missing. You really get down to it. So it's going to become more and more of a challenge in there. Is there a similar plugin for Revit? There may well be, not my thing, so I don't know on that question. All right, I think we've got time for one more question. And while we're doing that, I'll just finish up my slides. So, we have this product called ACDC. It allows you to get structured, self-validated, streamlined CAD data. It's in the cloud, it's consistent, and on the GIS side, you get accurate attributed data. And if you want to find out more, you can go to validation.openspatial.com or asconstructed.com. It's just that asconstructed is actually the landing page for the workhorse where people have portals and etc. So a lot more product information down here. Here's a question: can the CAD template be used by Trimble GPS devices? Survey department that works in conjunction. So the short answer is yes. And the more detailed answer is it's also, you'll find that a lot of the templates that the surveyors use are more, they don't necessarily capture all of the data that GIS is going to want. So they will have, it's a point, if it's a surface survey, they're going to go along and say, yep, this is a hydrant, or this is a manhole, it's a sewer manhole, but they're not going to give you what the diameter is of the pipe coming in at the other end. But any data that is on the survey side, yes, you can pull that in. And then there are, most of these folks have, most of these folks also do a whole lot of processing of the data from the survey into the structured data, and that's generally how the construction plans are built out. Okay.
Thank you, Colin. Such great information. We really appreciate everyone. Go make it a great day and tell a friend about Open Spatial and Directions Magazine. Thanks, everybody.